Hi everyone, welcome to day 3 of derivatives. Today's learning target is I can apply the product rule to find derivatives. So let's first recall using the power rule, find y prime if y is equal to x squared minus 1 times x plus 5. So remember, the first thing we have to do is expand and then use the power rule to find the derivative. Pause the video now and try it. So after expanding it, I got y is equal to x cubed plus 5x squared minus x minus 5. Now let's find the derivative. So 3 times 1 is 3, 3 minus 1 is 2, plus 2 times 5 is 10, 2 minus 1 is 1, and then I just take the coefficient in front of the x, which is minus 1. And there is my derivative. Now in today's lesson, we're going to learn a new rule called the product rule. If y and u are differentiable functions of x, then d of u of x over d of x is equal to u v prime plus v u prime. So this requires multiplication here and here. So the best way to apply the product rule is to apply it to an actual example. So let's look at example 1. Using the product rule, find y prime if y is equal to x squared minus 1 times x plus 5. So the first thing I'm going to do is I'm going to label this u and this v. So u is going to be x squared minus 1, and v is going to be x plus 5. Now we want to find u prime, which is the derivative. So applying the power rule, 2 times 1 is 2, x. Then what's v prime? Remember, we just like to take the coefficient in front of the x, which is just 1. So now what I'm going to do is y prime is equal to u v prime plus v u prime. So I am going to multiply u times v prime. So y prime is equal to x squared minus 1 times 1 plus. Then I'm going to multiply v times u prime. So x plus 5 times 2x. Notice you multiply the original by the opposite prime, or the opposite's derivative. So after multiplying, I'm going to get x squared minus 1 plus 2x squared plus 10x. Then combine like terms. I'm going to get 3x squared plus 10x minus 1. Now notice this is the exact same question as the first one we did, and we got the exact same answer. So you could do it either way. You could first expand and then apply the power rule, or you can apply the product rule by using this technique and getting the same exact answer. Let's try example 2. Given f of x equal to x squared plus 1 times x cubed plus 3, find f prime of x. So again, I like to label u and v. U is x squared plus 1. V is x cubed plus 3. Now let's find u prime, or the derivative of u. So that's going to be 2x. And the derivative of v prime is 3 times 1 is 3. X, 3 minus 1 is 2. So let's rewrite this out. Y prime is equal to u v prime plus v u prime. So let's substitute. Y prime is equal to u, so go multiply on the diagonals. X squared plus 1 times 3x squared plus x cubed plus 3 times 2x. Multiply that out, and I'm going to get 3x to the 4th plus 3x squared plus 2x to the 4th plus 6x. Combine like terms, and you end up getting 5x to the 4th plus 3x squared plus 6x. And that is my derivative. Again, you could have multiplied it out and expanded it and then applied the power rule, or you could do it this way with applying the product rule. If you turn to the next page, we have 3 example problems. It says find the derivatives of each of the functions below. So take a moment right now, pause the video, and try numbers 1 through 3. I will be using the product rule for each question, so I suggest you do the same. So here are the answers. So again, I represented u and v for each separate. So I made u x squared plus 3, v 2x minus 7. I rewrote them out, and then I took the derivative. So x squared plus 3, the derivative is 2x. The derivative of v is going to be 2. Remember, it's just the coefficient in front of the x. Then I applied the product rule. So I multiplied on the diagonals. So x squared plus 3 times 2 plus 2x minus 7 times 2x. And then I combined like terms, and I was able to get f prime of x is equal to 6x squared minus 14x plus 6. Number 2, f of x is equal to 2x plus 4 squared. Now, if I want to use the product rule, I have to represent this by 2x plus 4 times 2x plus 4. I write that representing u and v, and take the derivative of both. Just take the coefficient in front of the x, which is 2, and then again, I multiply on the diagonals. So 2x plus 4 times 2 plus 2x plus 4 times 2, and I'm left with the derivative f prime of x is equal to 8x plus 16. And lastly, for number 3, represent x cubed minus 1 is u, x squared plus 1 is v, and I find the derivatives. So to find the u prime, 3 times 1 is 3, 3 minus 1 is 2. 2 times 1 is 2, 2 minus 1 is 1. Multiply on the diagonals again. So x cubed minus 1 times 2x plus x squared plus 1 times 3x squared. Combine like terms, and I'm left with 5x to the 4th plus 3x squared minus 2x as my derivative f prime of x. On the next page, we have a little bit more challenging questions using the product rule. It says find the equations of the line tangent to the following functions at x equals 4. So first, you're going to apply the product rule as we did in the previous questions, and then you're going to find the slope using x equals 4. You're going to then find your y value from your original and then put it into the point slope form. So pause the video now, try that. So here are the answers. I know it looks a little bit daunting because there's a lot of work here, but we're just going to talk it out. So I represent u and v by each separate. I found the derivative of u. 4 times 8 is 32. 4 minus 1 is 3. 1 minus 9x squared, that derivative is negative 18x. So again, I multiplied on the diagonals and then I added them. So I'm left with this as my derivative. Okay, now in order to find the slope, I have to substitute when x is equal to 4. So I substitute 4 in, and this is going to be my slope. Kind of a crazy number. Then remember, I want to find my y value for when x is equal to 4 in the original equation. So I substituted 4 into 8x to the 4th times 1 minus 9x squared. So that's where I substituted 4 in here, and I got this large number. That represents my y1. I rewrote out the point slope form, and I substituted my values in. Just be careful because they're big numbers. They're big negative numbers. So I distributed, and then I subtracted over, and this is my tangent line. Again, I used the derivative to help find the slope, and then I used the original to find the y value of that corresponds to x is equal to 4. Number 5 requires the same amount of steps. F of x is equal to x cubed minus 2x times 3x squared. So again, take a moment, pause the video, apply the product rule, then substitute 4 in to find the slope, Then substitute 4 in to find the y value of the original equation, x cubed minus 2x times 3x squared, and then put it all into point slope formula in order to find the tangent line. So pause the video now and try that. All right, so here are the answers. So again, I represent u as x cubed minus 2x, v as 3x squared. I found the derivatives of both, 3x squared minus 2 and 6x. I multiply on the diagonals, and then I add them together. So I'm left, after combining all like terms, this is my derivative, 15x to the fourth minus 18x squared. And again, feel free to pause the video at any time if you want to see the math. Then I substituted 4 in for x to find the slope. So this represents the slope. I substituted 4 into the original x cubed minus 2x times 3x squared to find the y1 value. Then I substitute these values into the point slope form. So here's my y, here's my x, and here's the slope that we found. And I'm left with the equation y is equal to 3,552x minus 11,520. And that represents the slope, that represents the equation of the tangent line. Hope that was helpful. Message me with any questions. Have a great day.